today my topic is about greedy best first search. So this follows a logic of a greedy algorithm where it tries to get the nearest neighbor, and in a way it also uses a best first search algorithm where it tries to calculate the shortest path between the nodes or between a source to the goal node. So we just go into the deeper part of it. So what exactly is the greedy based first search? It attempts to find the promising shortest path. It might not be the shortest path. So we have to remember that. It is one of the shortest path, but it is not the shortest path. So why is that? We look into it. So the algorithm works by evaluating the cost of each possible path and then expanding the path with the lowest cost. So for example, if there is a node, there are two child nodes to the parent node, and when we expand that node, we have two child nodes. And if each of the child node have two different costs, so the lowest cost of the child will be taken into consideration, and that node will become the parent node, and it goes expanding. This process is repeated until the goal is reached. So this process will be reached until our goal is reached. So this process will be terminated after. So this is a basic algorithm how that greedy first search works. So greedy first search works by evaluating the cost of each possible path and then expanding the path with the lowest cost, which we saw earlier. This process is repeated until the goal is reached. The algorithm uses a heuristic function. So now what is a heuristic function? Heuristic function is basically defined as the straight line distance or the shortest path from that node to the goal node. It is a function which defines that. So it is pre-assumed. So according to that, we'll take the next considerable node. So if we have the least heuristic value function, heuristic functional value, then that node will be taken into consideration. In that way, we'll keep expanding the node. We'll keep expanding the node until we reach the goal. The heuristic function takes into account the cost of the current path and estimated cost of the remaining paths. So that function will calculate as I said earlier, it will calculate that particular path to the goal node. From that node to the goal node, it calculates that path. If that value is least, then we will consider that node. So that our goal node becomes the least distance goal. If the cost of the current path is lower than the estimated cost of the remaining path, then the current path is chosen. So in the same way. So if that path between the node and the goal node is least, then that path is chosen. And we will ignore the others. This process is repeated until the goal is reached. So what is the time complexity? In the worst case, it takes into consideration all the possible cases. So it reaches the least node or the least leaf of the tree. So basically becomes the height of the node. So in the worst case, the complexity is